Okay. So I am speaking for Group 2, and the arrangement was Phil and I co-chaired that.
Just tell me when you want me to go.
Yeah, and what I understood is if I did the summary closeout, then that meant he was going to write the paper. So I appreciate that arrangement, Sven.
That was our arrangement, Dennis.
Yeah, isn't that the way you understood it?
Yeah.
So our group was focusing on specific tools that can be used. And before I start, I want to make sure I preface. I do apologize. Our group was a little handicapped because we had Rick in our group. So, it held us back a little bit, but we were able to make it through it. The other thing, in terms of our summary, we took the approach that you all have looked at our slides. You've seen those, so we're not going back through all of the details of those. We're trying to just hit the highlights. Okay, so when we looked at day one, what we had come up with, one of the first things we did was defined insertion points. Somebody talked about engineering faculty. How would someone actually use this? And we really came up with 4 key pieces. One would be someone in their first year Introduction to Engineering class to begin to introduce systems thinking. The other would be project-based courses somewhere, specifically junior or sophomore, and then capstone course. And then the other was someone that just wanted to introduce specific topics within another course. So they wanted 1 or 2 lectures, just a couple topics that they were going to put in. So when we think about insertion points, those are really them. And he mentioned the resources. The first thing we did was we brainstormed what tools exist. So we came up with a list of about 25 things, and we all agreed, there were several of us in the room who do teach systems engineering to undergrads now. We all agreed really none of those are directly usable in their context. My wife tells me the same thing all the time. I think it's, the hearing, I'm getting a little older. Okay, is that better? Okay, very, very good. Yeah, so the thing that we all agreed to is there's great material out there, but none of the material is in a form that you could just give a student, you could give a faculty member, just you were saying the CBOT. They're not in that form. So then where we've kind of turned is to say, okay, well, what is needed? And so we came up with a whole list of things, and one that we added today was a key piece is defining what we really mean by systems engineering. So topics, differentiating systems thinking, systems science, traditional systems engineering, engineering systems. So that is one key thing that's needed, is defining that. And then we had a whole list of things. We started with resources for faculty, course modules, and again, if you looked at the poster, there was a whole list of things down there. So what we did today was we came back and we said, okay, let's focus on what we think are our top 2 things that we need. And the first one was modules that could be used by a faculty member. So somebody that, here's the first one that says, I'm on board, I want to do this. So we say, okay, here you go, here's a module that you could go use in your class. And then the second one was just resources to support faculty. Faculty that are on board with this, other than actual course modules, what resources to support them. So in there, first thing, let me talk about the modules real quick. So we came through some definitions for those modules. We said, okay, we're calling a module a 1 or 2 hour block of material. They are specifically at this point for undergraduates, non-systems engineering students. That's one of the things we had to keep reminding ourselves. We're not training systems engineers. We're training the mechanical, the electrical, the whatever, in some systems engineering topics. The module should take little effort from faculty to implement. From a practicality standpoint, all the things you mentioned on your negatives there, we felt that was pretty important. They will be evaluated based on, we need to develop that criteria. And really what we're talking about there is I go develop a module, I bring it in. Rick says, okay, let me put it through this litmus before we release it out to somebody to make sure that it is what we really want.
Map it to ABET criteria, too.
What's that?
Map it to ABET criteria.
Sure.
See what I'm saying?
Right, yes.
Then it's easy to do the math.
Mm-hmm.
Map it to ABET criteria.
Gotcha. Thank you. It should cover the fundamentals, but also paint the broader picture. And we put kind of a caveat there that because we are dealing with traditional discipline faculty, ME, AE, electrical engineering, this whole area is already fuzzy enough to them that if we're not careful, if what we give isn't pretty prescriptive and pretty wrapped, it's going to be very easy for them to look at it and say, look, I have no idea what you're talking about, and just discount it. So yeah, we want to keep the broader issues in mind, but it also has to be some pretty prescriptive, well-defined material that they can get their arms around and use it right then with their students. And then the last thing is that the module should come across as coming along beside their discipline knowledge, not standing above it. So, you know, they don't feel like, oh, the systems engineers are trying to come and tell me how to be an electrical engineer. So it needs to be done in a way that comes across like that. And then so what we did is we defined what we felt like were the 4 key topics that we should first go and develop modules for. And there's kind of a caveat at the top that's not saying this is it, but to start, this is what we would recommend. So there's kind of foundational, what we called systems thinking, and then a conceptual view of systems engineering. And kind of the idea, especially with the conceptual view, is students have a framework where they see where these ideas fit in. They see the big picture. And so as they're learning some of these details, they see how it fits into the whole. And then some detailed topics. And so really two main areas, the systems engineering technical processes, and then planning and control. So under that, we defined requirements definition. We heard that in this room as we were talking. One of the first things we did is everybody went around the room, and we had asked everyone to come up with, if you could only teach 3 things, what would those 3 be? And requirements was on everybody's list. So we pulled that as, okay, that would be the first technical process module that we would want. And then under planning and control, we said a systems approach to project planning and control. We initially just had project planning and control, but I think it was Rick brought out the point, you know, we're not talking about just traditional project management. We're talking about work breakdown structure that's driven by the design and realizing, okay, we have these subsystems, this one has this complexity, that means I'm going to need to build this into my schedule. So that's why we kind of added that systems approach to the planning and control. So those are our modules, kind of our vision and the key topics. And then the second thing we looked at was, again, brainstorming faculty support. So here's some things we came up with. Guest speakers and lecturers, and that's already been mentioned. The ability to get help to develop their own material. So a faculty that really wants to do this, but he wants to develop it. Resources that we can give them to help them develop their material. Simple online resources, like I think somebody mentioned, what's the word? Thank you very much. Yeah, something like that. Complete, and on there we're also talking about online resources like videos, you know, TED-like videos, anything like that that somebody could show in their class if they wanted to have an information module. Also, complete teaching packages, kind of like our module, you know, that would fit into that. So somebody that wants to develop their own, somebody who says, I'm on for it, but give it to me. Another idea was a way to get mentoring help. You know, maybe people around the country who are good, who are involved in this, who are willing to give online support, to do video conferencing, whatever. So a faculty member says, yes, I'm on board, I want to do this, but I've never done it before. I want somebody that can kind of hold my hand. When I run across this in class, and I'm not sure what to do, somebody that I can talk to. And then develop a pilot study that kind of explores the dimensions of doing this and specifically looks at the challenges between a small program and a large program. We had both in our group, and you know, sometimes it can go either way. What works at a small isn't going to scale down, or more often what works at the small doesn't scale up. You know, when you've got 30 students versus 1,000, it's a whole different environment. Also, new faculty versus tenure faculty. That's one of the things we talked a lot about, that probably our lowest hanging fruit is to be able to target newer faculty, to get them doing some of these things versus someone who's been around for a while. Okay, so kind of our overview summary of what we say next steps. You know, so when we pull from those brainstormings, we said, okay, what are our key things? One, we said we really want to package the message in some outreach activities. And so when I say the message of systems engineering for the non-systems engineer. And the one idea from all of our brainstorming that we said we would implement is the TED-like videos is probably the lowest hanging fruit there. is to develop some of those to get the message out in that kind of outreach activities. Package message and faculty support tools, guest lecturer, speaker list that could be given to people would be one, and then the other one is faculty development workshops. And two ideas that were thrown out again as low-hanging fruit is one, to get a module going at the Capstone Design Conference. And Fred is actually going to work on that and take care of that for sure. And also, now, was that your all Summer Institute that you all were talking about? Yeah, so one of the ideas that we had is, again, for low-hanging fruit, let's try to incorporate this with something that's already going on that people are already involved in. The other was the need for an information gathering instrument. So, you talked about survey or whatever else, same thing. And so we said integrate that with the full group. And then the last was to develop the modules for the classroom, which I already talked about. Okay, so that's kind of a...
Could you go back a couple of... Leave that one on the screen.
Yep.
So, Rick, are we just going to do the third one and then we'll talk?
Yeah.
Yes.
Okay. We've got 5 minutes for questions for this.
For right now? So,
yes.
All right, so... What's on? Okay. So go back a couple. I can't remember now.
Tell me when.
Okay, so... yes, so systems thinking and conceptual view. That's very similar to our chart that we had on systematic versus systemic, right? So it's just different terms, I think, for the same thing, right? I mean,
Yeah, well, and like when we say systems thinking, in our, and you guys correct me, I don't want to speak for the group, but we were really talking about the whole idea of learning to see wholes, systemic thinking versus analytic thinking.
Yes.
So just learning to realize, there's a different way of looking at the world.
Right.
The conceptual view of systems engineering is really kind of seen from a concept standpoint. What do we do? Taking requirements, bringing them down, embedding them into the design, then testing, verifying against those all the way as it's built back up. So understanding that conceptually, so then as you're learning the detailed technical processes, you kind of understand where things fit.
Right.
I mean, Sven, is that? Okay. Yes.
So you might say, well, why did we come up with, on those last two things, why did we choose those two, right? Because, there's a whole series of things we could do. And really what we were looking at is if we're anyway needing to go into classrooms where people are already doing things. So let's think, so I think we thought about the capstone design class, right? There are two things that they're anyway doing, trying to get the students to write specifications or requirements or translate customer needs in some way. And then also to plan the project out, to do Gantt charts. And so we thought, well, if we're anyway providing tools that let them do what they're anyway doing, but we're just doing it from a systems engineering flavor, that's going to be a lot easier sell than telling them they need all these other things. So we're already providing them material. I would say it was almost kind of like we're sneaking in this view of things. And particularly when it comes to, I think, the project planning, I mean, I see so many of my faculty say, oh, the students got to put together a Gantt chart. They put together this crappy Gantt chart, but at least it does that, and they check off that box. Students produced a Gantt chart, right? And then the first line is PDR, and I'm doing all these, not all the steps it take to get there. And so teaching it from a systems engineering viewpoint where you tie it to the work breakdown structure, which ties back to requirements. Anyway, we just thought that this was a low-hanging fruit that we could sneak it in anyway.
And there's a question behind you, Sven.
Have you guys at all considered the impact that you might have on students outside of the classroom? So perhaps targeting students that are working on various competition teams or projects that are not necessarily tied to a specific classroom, but are maybe interdisciplinary teams formed out of various types of engineering students. I feel like that might be a good place to try to introduce some of these systems concepts in a non-formal environment, and you might get a buy-in very quickly if you can show that some of those things work with students on a smaller scale.
Right. We did not. That's a great idea. That's another. If you think about our insertion points, that's actually another insertion point. That's a great idea.
You're welcome to come to WPI. That's how we do things.
Right.
The robot that you could see after 3 o'clock, and I went over there, and after 3 o'clock they will be testing it on the very top floor of the parking structure. They claim that one of the reasons that they have done so well is because, in fact, as an interdisciplinary project, they've taken a systems approach, and I keep giving them a hard time about that, to do it.
Yeah, yeah, great idea. Like I said, that we need to. I'll add that to one of our insertion points because that is another. If you think of low-hanging fruit, you get a motivated group and a faculty member that's willing to work and teach them a little. That's an easy. Right. Yep. Good. Okay. I think maybe we got time for one more. Yeah. We're done at 10 till.
So what you were just saying made me realize that non-engineering, practical disciplines like design, design schools maybe would also benefit from this conceptual view of SE, and they might be open to wanting their students to already be familiar with the SE approach.
Yeah, I think that's a good point. We came into this saying we were going to look at engineering students, and while I still think that's a good target, I think we have to be careful that we're not bounding too closely. And I think things like design are worth maybe thinking about in where we go with this in the future. So I'm all for bounding things, but not too tightly. So if that becomes a dogma, that we're talking about engineers and we're talking about university education, then that becomes counterproductive. So we'll continue to challenge whether there's a knock-on effect or a spin-off that we could also do for other domains. So yeah, we should keep reminding us of that.
Group 3.
Okay. Thank you, Bill.